Hello, this is Dr. K. In this video, we're going to talk about the data access object pattern, how to implement it with JDBC, and how to use it with transactions. As a reminder, the data access object pattern contains model objects that model the rows of the tables in our database. The DAO pattern that we use has immutable model objects. They only have getter methods for the fields. The DAO objects provide the CRUD operations for our database tables: create, read, update, and destroy. In practice, we're only going to add methods to our DAO classes that we need in our application. The simple Affable Bean project uses JDBC implementations for the DAO interfaces. To get a connection to the database, the DAO implementations call the getConnection method from the JDBC utility class. Finally, the application context, a singleton class, ensures that any DAO objects used in the controller servlets are effectively singletons. This is a screenshot from the MySQL workbench. It shows an enhanced entity relationship diagram of the database used in the simple Affable Bean project. We have categories, products, customers, orders, and line items. This is a model class based on the product table in the database. Notice that the fields from the database become private instance variables in our model class. We have a constructor that sets all of the fields, and we have getters, but not setters, for each of the fields. The fact that we only have getters for the fields makes our model classes immutable, which is a desirable property to have when working with databases. When mapping SQL database types to types in Java model classes, the simple Affable Bean project uses a mapping similar to this. Any integer that represents a primary or foreign key becomes a long integer in the model class. Ints and small ints become Java ints. Varchars become strings. Dates and timestamps become Java util dates, and booleans map to booleans. Before creating a DAO interface, we try to anticipate what methods we're going to need in our application. Typically, this is use case driven. We look at the data we might need for various web pages, and we look at the forms we're likely to submit. A good place to start is with methods that find or read data. The findAll method returns all of the products in our database. Because we generally expect there to be a lot of products in our application, it's doubtful that we would ever want to return all of the products to display on a web page. However, we're going to keep this method in the interface because we want to talk about its implementation later. The findByProductID method takes a primary key and returns the product associated with it. We are certain to need this functionality in our application. Another useful functionality might be to return all the products from a given category. Notice that the category ID is a foreign key in the product table. Let's look at a JDBC implementation of these three methods. First, notice that we have created string constants for each SQL query that we're going to perform. Whenever some part of that query is not known until runtime, we use a question mark as a placeholder for the parameter that will be determined at runtime. The readProduct method takes a result set and returns a product. Recall that a result set is a Java object that corresponds to the result of an SQL query. Since we're going to be needing to obtain products from the result sets in each of our find methods, we are encapsulating this functionality into a private helper method called readProduct. Before we look at any of the find implementations, I want to introduce a mechanism that all three of them use, the try with resources statement. This was introduced in Java 7 as a way to simplify your code when you have resources that need to be closed regardless of whether an exception is thrown or not. The try with resources statement puts these resources in parentheses right after the try keyword. When you use it, Java will automatically close the resources for you whether or not an exception occurs. Let's look at the implementation of the findAll method. The method returns a list of products, so we create an empty list at the beginning. The try with resources statement takes three resources: a connection, a prepared statement that prepares the SQL query, and a result set, which holds the result of that query. Notice that the prepared statement is constructed using the findAll SQL query string we created earlier. The while loop simply loops through the result set and adds all the products it contains into the list. As long as no exceptions occur, the list is returned. Now let's look at the findByProductID method. This method takes a primary key and returns the corresponding product. We declare a product object at the beginning. Then we use a try with resources statement that contains two resources, a connection and a statement. We cannot include the result set with the other two resources because the statement needs to be modified before we can get the result. The statement needs to be modified because it takes a parameter. If you go back and look at the findByProductID SQL query, you'll see that it has a question mark in it where the product ID needs to go. We use the setLong method on the statement to set the product ID. Then we use another try with resources statement to declare and initialize the result set resource to the result of the query. If the result set contains at least one element, we take the product in the first element and return it, as long as no errors occur. Finally, let's look at the findByCategoryID method. This method is similar to the findByProductID method, except that it returns a list of all products associated with the category instead of just the single product associated with the given primary key.